Hello everyone. In this video, we talk about iteration in Python programming. Iteration is a fundamental concept in programming that allows you to repeatedly execute a block of code. And there are several ways to implement iteration. The most popular one is using a for loop, but there are other options too, such as while loops and comprehensions. Let's get started with for loops. So the syntax for loops is very simple. You have to use this for, and then the name of the variable that you want. So that's why I like to use here variable, but obviously this is optional. You can say for item, for I, or any other name that you want. So you can just choose the name of the variable that you want. In, and then after this in, you need to have an iterable. So what is an iterable? Iterable is a Python object which is capable of returning its elements or members one at a time. So this means that now you can iterate over these elements using a for loop. Examples of these iterables include Python lists, tuples, strings. We are familiar with these when we talk about Python data structures. It can also be a NumPy array. So there are many different forms of iterables. And so the way it works, you say for some variable in this iterable, or let's say for now a Python list, I want to run this piece of code, right? And very similar to if statements, the way this works is that you use colon, and after that, you will need this indentation or these spaces to show that this block of code falls within this for loop, right? So that's how we know what is included inside this for loop using this indentation. And I'm going to talk about this when we go through the code cells in a few moments. But one thing that we can also talk about here is that you may wonder how this works, this idea of iterating over elements, right? Because we need to somehow keep track of what elements we have already observed and what is the next element to retrieve from that iterable. And in order to do this, the way that Python works, we need to have an iterator. And you shouldn't confuse iterator with iterable. They're two different things. What iterator is like an object which keeps track of the current state of the iteration, meaning that what elements have been retrieved and what is the next element to be retrieved. And for that, we can use the next function or method. We don't really need to use iterators very much in this course, but just to show you how this works, let's look at this Python list, which is obviously an iterable because we can iterate over its elements, as we just discussed. And you can use the iter method or function to create an iterator out of this object, right? And now we use this next method that we just discussed about, right? So far we have not retrieved anything from this Python list here. So if I run this cell, as you expect, you should get 1, right? Because that's the first element that we have there. But now this iterator knows that you have retrieved the first element. So now when you use next, you're going to have the next element, right? And we can see that that's what we get here if we run this cell. And similarly here, if I run this one more time, we get 3. If we do this one more time, and if we do this one more time, right? So that's why this iterator is very important to keep track of what we have retrieved and what is the next element to be retrieved. And if for whatever reason, you want to retrieve another element from this list, you can see that you get an error message which says stop iteration. And the reason for this is very clear because this list has only 5 elements. So once you get to this element, there is no next element, right? You expect that you should get an error message to tell you that, well, there's nothing else to be retrieved at this time, right? And that's what exactly this thing is. And as I said, we don't really need to use iterators in this course. What we really want to learn to use is for loop, right? So we say for some name here called a variable. In this iterable object, remember, iterable object is this list that we have here, this line. So you don't need at all to use iter or next. So you just have the list, and then you're going to print each variable. Ideally, you want to do something more sophisticated with these variables, but right now we want to keep this as simple as possible to understand how for loops work. And for that reason, we just print this variable that we retrieve from this list. And as I said, we need to make sure that we always use this colon, otherwise we will get an error message. And once you do this, if you press enter, you can see that we come to this sort of like indented line, right? So there are 4 spaces here, which is the standard indentation. And you can see that anything that is this indentation is part of this for loop, right? So right now, this is not part of for loop because it doesn't have that indentation, but you can, again, just use enter, and you can see that now we have these 4 spaces. And if I run this, we get 1, 2, 3, 4, 5. As we said, this is arbitrary. I can just call this item instead of variable, and you can see that we get exactly the same result. So this is just a name that we assign to each element that we retrieve, and you can decide any name that you want. Obviously, we discussed this before. You cannot start a variable name by a digit or something like that, by a number. So these are things that we have to follow, but other than that, you can choose any name that you want. There are also other types of iterables. One of the, useful ones is NumPy arrays. And here we are using np.arrange 1, 6, which means that we want to iterate from 1 up to 6. So 6 is not included and is actually excluded. So you can see that if I run this, I get 1 through 5. If for whatever reason you want to include 6 here, then you need to increase this to be 7, then you get 6, right? So that's why to just remember always the stopping point is excluded. Okay, so now let's exercise a bit more. Let's say we want to find the factorial of a positive integer. So what is a factorial? Factorial is the product of all integers up to n. So meaning that if you want to find factorial of 3, then you have to multiply 1 by 2, and then the result of that by 3, which means that you get 6. If you want to find factorial of 4, then you have to multiply 1 by 2, and then by 3, and then by 4, right? And in this case, it's up to n and including n, right? And therefore, factorial of 4 is 2 times 3, which is 6. 6 times 4 is 24. But how can we implement this using a for loop in Python, right? So let's say you want to write a Python function that can calculate factorial for any positive integer n. So you can use the def keyword here. Again, similar to for loops, if statements, you need to use colon. We need to use the indentation to show that this is part of this def block or def block. You need to use docstring. It's always a good practice to explain what this function is, what input arguments we have, what it returns. In this case, it's simple, but it's still a good idea to include that. It's always a good idea to have safety checks. If for whatever reason you're given a negative integer, then you shouldn't even try to find the factorial, right? So in that case, you can use this if statement and return none, which means that there's no result, right? None means the absence of a value. And remember, once you get to return, if this statement is true, then you are exiting this function, right? So you're returning none, and you're not going to go through the rest of this code. But if n is greater than 0, then you have to start finding these factorial. So remember, if you have, let's say, factorial of 3, 4, 5, 10, you have to always start from 1, right? And 1 times 1 is basically 1. So that's why we initialize this variable result to be 1. And then we include this for loop to go through sequence of numbers starting from 1 up to n, and n should be included. So that's why here we are using this range. So range in Python is very similar to np.arrange, right? The starting point is always included. The stopping point is excluded. So when we put n plus 1, means that we are going to go from 1 through n, which that's what we want to do. And what you do is that you're going to multiply the result that you already have by this I that you retrieve from this list, and you're going to update the result, right? So this is basically, I can show you what it means. So this means that you want to update the result by multiplying result by I, right? So in this case, right, so first I result is 1, right? And so once you get to 2 here, right, like let's say 1, 2, then you multiply 1 and 2, and now the new result is 2, right? And then when you retrieve the next I, which is 3, then you multiply 3 by 2, which is 6. And similarly, now when you go to I equals 4, now you multiply 4 by 6, which is 24, right? That's exactly how factorial works. So in this case, we retrieve these elements one by one, multiply by the current result. So that's what you have on the right side. And then remember, equality here means assignment, right? That's what it means in programming. So this means that you're going to update this new value to the result and update it. And once you're done with this for loop, right? So this is what is done inside the for loop, you're going to return the result. Okay, so let's see how this works if you provide n equals 4, right? So in this case, you have to go through 1, 2, 3, 4. And we are, as you can see here, using this print statement, the factorial for n equals 4, because that's what we have assigned here, is 24. But I like the more compact form. So what I'm gonna do, I'm gonna remove this line, and I'm gonna remove the comment here. And I'm gonna use this simplified notation. And what this means is that you're gonna multiply result by I and update it. And I run this cell again to just show you we get the same result. And you can see that still the result is 24 as expected. So this is one real world example of using for loop for solving this mathematical problem. But you can also use for loops to iterate over elements of dictionaries. Remember, in Python dictionaries, we have key value pairs, right? And like, for example, like here, right? So the keys are these A, B, C, and the values are 1, 2, and 3. So what if we want to iterate over these key value pairs to do some computation? Now, here we are printing just these key value pairs, but in general, we may want to do more sophisticated operations. And as you can see, we have a method for dictionaries which is called items.items, and I forgot to run the previous cell. So before this, my dictionary was not even defined. So once we define it, actually, you can see that if you use .items, we know that what this does, it returns a list. And remember, a list is iterable, meaning that you can iterate over its elements. And each element is actually a tuple, where you have one key and the corresponding value. So this means that if you want to iterate over these key value pairs, what you can do, you can say for, and remember, because now we have these tuples, we actually have 2 items here, right? So that's why we here also need to use 2 items. Obviously, these names are arbitrary or optional, but I like to use key and value to remember, okay, the first one is key, the second one is value. In this dictionary.items, we want to print keys and print values. And this is, as you can see how it works. So remember, Python is smart enough to know that when you use this key value in dictionary.items, that the first one, which is key, corresponds to A, and the second one corresponds to the second element, right? So if for whatever reason you have a tuple with 3 elements, then you need to have 1 item, 2 item, and then the third item, right? So here we don't have it, and I'm gonna erase that, but that's something to always important to know, that if you get multiple elements, also you need multiple names so that way this for loop is going to work the way expected. The other thing which is very important when you're using any kind of iteration in Python or other programming languages is that sometimes you may need to stop the iteration sooner than expected, right? So you may have a for loop, you want to go through all the elements of like a list, like what you have here. But let's say your goal is just to find the item with value 5 and then stop, because that's when what you really care about, finding this item with value 5. So in that case, you can use the break keyword. So the break keyword is used to immediately exit or break out of the most immediate for loop that it contains, right? And I'm going to explain what we say here, the most immediate for loop, because you may have multiple for loops, but let's start with a simple case where you only have one for loop. So in this case, as we said, you can write this for loop and say for num in numbers, and numbers you can see is this list. If this num equals to 5, right now we are using this equal sign. So this means that we want to check to see whether the value of num is actually 5 or not. And if this condition is true, right, now we want to print that, oh, we found 5, and we want to leave this for loop. And after that, we don't want to go through the rest of the elements, right? So we're using break. So what this does, this break looks at this for loop and says that, well, because now I got to break, I have to stop this iteration that is defined through this for loop right now, right? And you can see that here. Otherwise, if we continue, we print the number that we have. So I want to add these to show you actually when we are stopping this for loop that we have here. And if I run this, so you can see that we start with the first value, which is 1. And obviously 1 is not equal to 5, right? So we are not going to go through any of these things here, right? Because this statement is not true. And we print num, which is 1. And then we go through 2, and it's still this if statement. We don't go inside it because this condition is not true, and we print that until we have num equals 5, right? Then we print this item, which is found 5, but we do not anymore print that num 5 in the next line because we have seen this break keyword here. And what this means is that we have to leave this for loop right now. So we don't get to actually print 5. You see there's like 1, 2, 3, 4. There is no 5. We just have this statement, and that's what is coming from this print statement that we have here. And I wanted to show that if you want to use something which is outside of this for loop that we have here, then it's very easy. You just have to remove the indentation and go back to the beginning of the line, right? So then regardless of whatever happens in this for loop, we always print this because this doesn't have anything to do with the for loop because it's not inside the for loop in a way that it doesn't have that indentation. But let's look at what happens if we use break keyword. If you have a nested loop, right? Meaning that if you have like 2 for loops, like what we have here. So here the goal is this. We have 2 numbers. Think of them as x and y. And we know that x is from 1 to 5 because 6 is not included. And y is also from 1 to 5, which is, because again, 6 is not included. And we want to find the combinations such that the sum of these two, these x and y, or here we call them I and j, is equal to 8, right? So we start with the outer for loop, right? That's what I call outer for loop. And I call this the inner for loop, right? So first we're gonna set I equals 1 using this other for loop. And we're gonna now, inside this other for loop, increase j from 1 through 5, right? So we know that if we add 1 and 1, we get 2, so that's not 8. Even if we add 1 and 5, we get 6, which is not 8. So there is no way we can have I equals 1, and then we have another value of j in this range where we get 8, right? What if I equals 2? In order for I equals 2 to get 8, the sum of the two, we need j equals 6, and that's not the case because this is excluded. So the first time is when I equals 3, right? So if I equals 3, then for j equals 5, which is inside this range, we get the sum of 2 is equal to 8, which means that we're going to go through this if statement. We're going to print the fact that we found a pair with this sum equals 8. And we're going to use this break. But remember, this break goes back, and finds this for loop. And this is the iteration that we are going to stop. We are not going to stop the iteration for the outer for loop, right? So this means that now we can actually go from I equals 3 to I equals 4 and repeat the same process again, right? So we just have to stop this inner for loop. And if I run this, you will see that this is actually the case, right? Because we're going to find the first pair, which is 3 and 5. Obviously, the sum is 8. But then we're going to increase I to 4. There is another actually pair, which is I equals 4, j equals 4. And then there is also another pair where I equals 5 and j equals 3. And after that, we don't have any other pairs. So that's something important to know, that this break is not stopping both of these for loops. It's just stopping the closest or the innermost for loop, which is this one, which comes very handy in this case because you're able now to find all these pairs where the sum is 8. Okay, so this is for loops. Similarly, we can use while loops. The main difference between the two is that for while loops, we just have to put a condition, like very similar to when you use an if statement. And you're gonna run this block of code as long as the condition is true. So this is very helpful where the number of iterations is not known beforehand, right? If you know the number of iterations beforehand, you can just use a for loop and say np.arrange or range if you're using Python and provide the number of iterations that you need. But sometimes we want to continue something until something else happens, right? So that's when this while loop becomes very important with this syntax, right? So while some condition, again, indentation, and that's how we show what's included inside this while loop. So let's look at a real world example of this. Like, why should we use while loops? Let's say you want to solve this problem where you are looking to solve this problem where the goal is to find the smallest power of 2 that is greater than a given threshold, right? So let's say the threshold is 100, as you can see here, right? So if you remember the powers of 2, right? 2 to the power of 6 is 64, right? So it's smaller than the threshold. But 2 to the power of 7, right, is 2 times 64 is 128, which is just above 100. And then obviously you have 2 to the power of 8, which is 256, etc., right? But in this case, the solution should be 7, right? Because 7 is the smallest power of 2 that is greater than this threshold 100. So how can we solve this problem for any threshold that is provided? So you can always start with power of 2 to be 1. That's how we initialize this variable. And obviously, we need to keep track of the power of the 2 raised to this power, which is 1. So 2 to the 1 is equal to 2. So that's the current value. So now the condition that we have here for this while loop is that if this current value is less than or equal to threshold, let's do these 2 lines of code, right? Why? Because if the current value, meaning that 2 raised to the power of that number that we have there, is past the threshold, then we have to stop, right? Because we found the solution that we want. But if this current value is less than the threshold, then let's increase this power of 2 by 1, right? So remember, this is very similar to what we had before. So this line is equivalent to saying that we have power of 2 plus 1, right? So adding 1 to the power of 2 and then updating it, right? Because this equality sign is assignment operator in Python programming, right? So that's what this line is doing. But I like the more compact notation. So in this case, if current value is less than threshold, we're going to increase the power of 2 by 1. And then we're going to update the value of the current value, which is 2 raised to the power of this number that we have here. And now we're going to again check whether current value is less than threshold or not, right? So when power of 2 is equal to 6, right, then we get 2 raised to the power of 6, which is 64, right? And 64 is less than 100. And in that case, we're going to increase that power of 2 by 1, which means that now we get 7. And 2 to the power of 7 is 128. And this time, when we check, 128 is actually greater than 100. So this means that we have to stop, right? That's how while loop works. We're going to go iterate until some condition is met. And that's exactly the solution that we are looking for, right? So if I run this cell, you can see that now we stop at 7, and you can see that the smallest power of 2 that is greater than 100 is 2 to the 7, which is 128. If we want, we can change this threshold to be 60, right? In this case, let's run this cell again. So the smallest power of 2 greater than 60 is 2 to the power of 6, which is 64, right? And that really makes sense. So therefore, you can see that this code is actually working, right? You can obviously choose different thresholds, but it is working as expected. The other thing which is very important is the continue keyword, right? So we know already the break keyword, which means that a stop iteration, especially when you have a for loop or even a while loop. But the continue keyword is a little bit different in a sense that what it means is that you want to skip the rest of the code inside the loop for the current iteration and jump to the next iteration, right? So we don't want to fully stop the for loop or while loop that we have, but we want to go to the next iteration. So let's say that, we want to start from 0 and increase these values up to 10 and skip printing even numbers, just print odd numbers, right? So you're gonna increase I by 1. This means that you're gonna add 1 to the I and update it. And you're saying that if the remainder of dividing I by 2 is equal to 0, that means that it's an even number, then continue, which means that skip the rest of what's included inside this while loop, right? So you're not gonna print this. But if it's an odd number, right, then this statement here is not true, which means that you're not going to see this continue, right? So you, from this line, you go through that line, and so that way you can print that current number. And you can see that this is actually the case, right? So for odd numbers, 1, 3, 5, 7, 9, you're going to get to this print statement and actually print the current number. However, if you get an even number, this condition is true. You see the continue keyword, which means that we are going to ignore whatever the rest of this while loop is, right? So both of these keywords are very important, break and continue, and they have different implications. And just to show you the difference, what would happen if instead of this continue, we use break, right? So the way it works, we go back and find this for while loop, which is this while loop. In this case, this means that the first time you get this break, you have to stop iterating, and therefore there is no more next iterations, right? So in this case, you can see that we only get one print, right? Because we're going to increase I by 1 when we start from 0. So you get 1. And for the first case, obviously, the remainder of dividing by 2 is not equal to 0. So we are not going to go through this if statement. So we can print this. But once I equals 2, then the remainder is 0. And we see the break here, which means that we have to stop iterating. We don't have any more future iterations. And as you can see, that's what this means. Finally, let's talk about list comprehensions, which is a very important topic. So sometimes, very similar to when we defined the lambda functions before, you do not want to write the whole for some item or variable in an iterable colon and then use the indentation and then define new variables and perform some operations. And you want to do this in a very simplified form because in some cases, you want, let's say, retrieve some items from a list, multiply them by 2 or square them and just store the result, right? So you want to perform something simple. And in order to do this, you can use list comprehension with this syntax that we have here, right? So you use for some item or any name that you want in this iterable. This is the expression that you have. Meaning that, let's say, if you want to do some operations or perform something else on this item. And the cool thing is that you can also add an if statement too. So all in single line. And just to show you how you can use this to use this as a concise way of creating lists based on existing iterables or list. Let's say that you have this list of numbers 1 through 5. And what you're saying is that for each x in this list, raise them to the power of 2 and save the result in another list called squares, right? If you run this, you can see that we get 1, 4, 9, 16, and 25, right? Even we can add some conditions, right? So this is exactly what we had before. However, you can use an if statement and saying that if x the remainder of dividing x by 2 is equal to 0, then perform these operations, right? So this means that we want to only square these elements if they are even numbers, right? Because that's what this if statement here is. So in this case, you only have 2 and 4, and these are the 2 numbers that are eligible. So now, let's practice a little bit more. So let's look at prime numbers, right? So what is a prime number? A prime number is a positive integer greater than 1 that has no positive divisors other than 1 and itself, right? For example, 5 is a prime number because you can divide 5 by 1 and 5, right? Or like, for example, 7 is a prime number because you can divide it by 1 and itself, which is 7, but 9 is not a prime number because you can divide 9 by 3, right? And then the remainder is 0, right? So that's how we define prime numbers. And let's say if we can use what we have learned about list comprehensions to find prime numbers up to some number, right? So first you need to define a function to check whether a number is prime or not, right? As you can see, we put first an if statement and saying that if num is less than 2, then we return false, right? Because we know that the first prime number that we have is 2, right? And the way that we can check whether a number is prime or not is very simple, right? You have to consider all the integers up to that number, let's say n or num here, and see whether we get the remainder of the division to be 0 or not. If it's 0, then it's false because that's not a prime number. But if you check all the numbers up to n and you don't find any remainder to be 0, then it's a prime number. And in order to do this, you can write a for loop and go from 2 to exactly up to that number that we want to check. But actually, we can show that iterate from elements from 2 to the square root of that number, right? That's why I'm using num raised to the power of 0.5. We don't go through details of this because it's beyond the scope of this course. But if you want, you can also iterate through all the elements from 2 to exactly that number, but you can actually save a lot of computation by looking at the elements up to a square root of that number. And after that, it's very simple, right? So you're gonna just use this if statement and see whether the remainder of the division by I is 0 or not. If it is equal to 0, you have to return false because that number is not a prime number. And if you go through all these numbers and you don't return anything, meaning that there is no remainder which is exactly 0, then you're going to return true, meaning that yes, that's a prime number because I check everything and we don't have that remainder which is 0. And after that, in order to find the list of all prime numbers, you can use list comprehension, right? So you have this for loop, which is saying that for number in range of 2 to limit plus 1, because remember, if you want to include the limit, which is 20 here, we have to use this plus 1 to make sure that it's included. If this is prime num is true, meaning that it's a prime number, then return that. Otherwise, if it's false, we are not going to select that number. And if I run this cell, you can see that now we get all the prime numbers up to 20. We have 2, 3, 5, 7, 11, 13, 17, and 19. So this code works as expected. So that's something I would say is important to kind of practice and write it on your own. Try to replicate these ideas. It's a very nice exercise to show you how you can use for loops, if statements, and also list comprehensions. And just like list comprehensions, we can have dictionary comprehensions too. It's something that is less commonly used, but it's something important to know. So in this case, again, we have this dictionary with these keys and values, and you can use this for loop here, where you have key values in this dictionary.items, right? So that's what you get the list of keys and values, and then you keep the key, but for the value, you define a lambda function. So this means that for whatever this input is, right, you want to multiply by 2 and then add 3, right? So if I run this, so you can see that now I get this new dictionary, although I don't really square elements of this, I just wanted to still call it a square dictionary. But you can see that the first value is 5, which is 2 times 1 plus 3, and then 2 times 2 plus 3, which is 7, and 2 times 3 plus 3, which we get 9. Okay, so now let's look at quickly at the homework for this lecture on iteration. The first one, we want to have a Python function. So in this case, you actually have to write a Python function using the def statement or keyword that adds elements of a given NumPy array with even indices using a for loop, right? So here, for example, we have a test case. Your code should work with any given 1D NumPy array. But in this case, we have this test case that you can use to make sure that your code is running. So remember, the first index is 0, the next one is 1, 2, and here you want to add all the elements with even indices, 0, 2, 4, 6, and so on. So very similar to what ideas that you have seen, you can use if statement and use the remainder or modulo operation to see whether you have an even or odd index. The next question, you want to define another function, which is called custom numpy max, to find the maximum or largest value in a 1D numpy array. And the goal here is obviously not to use the built-in numpy function. You have to define and write your own way of finding the maximum or largest value. And you can use this test case in this case that we have. And just to give you an idea, one way to look at this problem is that you can iterate through these elements, right? Because this lecture is about for loops, while loops, etc. So you can iterate through these elements and always store the value of the largest element that you have seen, right? So meaning that for the first case, you see -2, that's the largest value that you have seen, right? And then when you go to the next one, 17, you ask yourself, is 17 greater than -2? And if it's true, then update the variable which keeps track of the maximum value, right? So that's one way of thinking about finding the maximum value in a given list that you can implement in this case using a for. We have a similar problem for in the third problem. And in this case, we take a positive integer as input, and we want to return the sum of the squares of even numbers from 1 to n, right? So if n is 19, for example, then you want to find even numbers like 2, 4, 6, up to 19 that we have, and also square them and add them together, right? So you can use a for loop and possibly some if statements and store this value, which should be the sum of the squares of even numbers. Problem 4 is definitely an interesting problem where you have two 2D numpy arrays, also known as matrices. One is m by p, and the other one is p by n. So obviously you can multiply these two matrices because the neighboring dimensions do match, meaning that p is equal to p. And if you do the multiplication, you get a matrix or 2D array of size m by n. So if you remember from the lecture on numpy arrays, you can use np.mathmul to solve this problem. This is already built in. But in this case, we want to write our own function. And this function, which we call my matrix multiplication a and b, is supposed to find the answer using a for loop. And also, it's better to say that using for loops, because you will see that you actually need 3 for loops to write this. So this is a really good practice. So what is happening here, I'll show you in the next slide. So in this case, we have 2D array or matrix A, which is m by p, and then we have B, which is p by n. And in order to do this matrix multiplication, we know that if we show the result by C, and if we want to find the value of the element at location with index I and j, so this is like one element that you have here. In order to do these, you actually have to go through the ith row of A. So you can see that we have actually p elements here, right? Because we have p columns. And then the jth column of B, the second array that we have. And we also have p elements here because we have p rows, right? So you can see that that's why these two numbers should match. And what you do is that you multiply the corresponding elements, and sum all of them together. So we end up with a single number. So that's exactly this for loop or summation that you can see in this problem, where we have this AI case where I is the number, the index for the row, and K shows that we want to iterate over all these different elements that we have. And we multiply this by B, K, J, right? So these are the fixed I and J that we have, and this for loop or summation is over K. But this is not enough because remember, this only gives you one element that we have here, but you want to find all these elements across the rows of C and all the elements across the columns of C's. So you need two more for loops to iterate through all possible values of i's and j's. And therefore, you should be able to implement these using 3 for loops. So we have also here a test case that you can use to make sure that your code is running as expected. You can, as explained here, compare these or verify the correctness of your code using np.metrics multiplication, which is the built-in method. And then we also have another problem where the goal is that you are given a Python list, like what's given here in this test case, and you have some minimum for valid numbers and maximum. And the idea is that you may have some faulty readings or some extreme or invalid values. And you want to do data cleaning here, meaning that you want to exclude the elements that are not between this mean and max value. And therefore here the goal is to write a function which is called clean temperature data, where you provide this list and these two mean and max values, and you're supposed to iterate through these elements and figure out whether they satisfy this condition. And if they satisfy this condition, you're going to keep them. And finally, we have an interesting problem where you have to write another function where given a Python list, which is like a 1D array, as you can see here, you want to find the maximum number of consecutive elements that are above the given threshold, right? So meaning that here, for example, the threshold 5, you can see that 5, 7, there are two elements that are greater than 5. Although here, I think the way that we have defined this is be above the threshold. So this means that, okay. So for the last problem, we want to write a Python function, count consecutive above threshold, where given a 1D array or a Python list, as you can see here, find the maximum number of consecutive elements that are above the given threshold, right? So for example, you can see here 6, 8, and 10, right? They're all above the threshold of 5, and they're consecutive elements. So that's basically 3 numbers where we have consecutive elements above the threshold. So we want to count this number if we have given a any sort of like Python list, right? How can we find the maximum number of consecutive elements in the list that are above the given threshold? And in this case, the goal is to use a while loop, as the problem says. So you can have a while loop to iterate through the elements of this list that we have, and then you have to keep track of the number of times that these consecutive elements that are above the threshold, right? And once you go below the threshold, then you have to start again from 0, right? Because in this case, let's say we start from the beginning of this list, we have 1, 3, 5, so they're all below the threshold because we want to have absolutely greater than the threshold. And we have 7, so that's 1. And then we go to 4, so this means that now we have to stop counting from now. So that means that we have 1 element above the threshold, and then we have 3 consecutive elements above the threshold. So in this case, the answer should be 3. But we want to make sure that this code works for any Python list.